Welcome back to my channel. In today's video, I will discuss about nitrogen bases. And we know that the nitrogen bases, they form a part of the RNA, DNA, so they are very important. And nitrogen bases, basically they are like two types, purines and pyrimidines. So in this video, we'll be focusing on the purines, especially the structure of purine. So how to draw the structure of purine. So I have given three basic points here now regarding the purines. So purine is a 9-membered ring and it is bicyclic, and out of the 9 positions, totally available position will be 9. So in the first position 1, 3, 7, 9, in these positions nitrogen atom will be present, and the remaining positions the carbon atom will be present. So first let us make a rough structure now. So because it's a 9-membered ring, normally when you take a benzene, because you will be aware of the structure of benzene. So you start from here, the number, like start the numbers from here, 1. You can give the number except from this question, 1, 2, 3, 4, and this will be 5 and 6. The 7th question you can make it here, 8th question here, and the 9th question here. So now you can join this 7th question, 8th question, and the 9th question, and you can join this also. So if we check the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, like this you have to make the skeleton structure. And now it is a 9-membered ring. It's a 9-membered ring, bicyclic, 2 cycles. So 2 rings, so we call it as bicyclic. Then 1, 3, 7, 9, we got nitrogen. So first position, third position, 7th position, and 9th position nitrogen. So remaining we got that carbon. So normally we know that in case of benzene, we'll be having alternative double and single bonds. So if we make a double bond here, then this will be a single bond, this will be another double bond, this will be a single bond, this will be a double bond. Now we know that here we can't have a double bond, alternative, na? Here also we can't have a double bond. So probably can make the double bond between 8 and 9 or the 7 and 8 like this. Fine. So now the 2 rings are ready and the double bonds you have mentioned there. Now let us replace by the atoms. So when we take question number 1, 3, 7, 9, we know nitrogen. So first question I will make a nitrogen. Second question is carbon. Because 1, 3, 7, 9, third only nitrogen, getting it. So in third position I will go with the nitrogen. Then fourth position carbon. Again fifth position carbon. And our sixth position will be carbon in this case. And 7 we got a nitrogen, so 7th position I will go with the nitrogen, and 8 will be a carbon, and 9th position will be a nitrogen. I can join this. Now let me make this double bonds here. So I have got a double bond here, I have got a double bond here, and the double bond here. So here I can't have a double bond, here also I can't have a double bond. I can make it here or here I can make it. Fine. Now the last step is valency. So start from 1, from the nitrogen atom. Nitrogen valency is 3. It has made 2 bonds and 3 bonds. Done. Carbon, it has made 1 bond and 2 bonds here, totally 3. So one more we can put the hydrogen to make the valency 4. In case of nitrogen, 1, 2 and 3. Fine. In this carbon, 1, 2, 3, 4. Done. This carbon, 1, 2, 3, 4. And coming to the 7th nitrogen, 1, 2, 3. It has valency satisfied. And coming to the carbon, 1, 2 and 3. So we can go with the hydrogen. And coming to the nitrogen, it has made 1 and 1, 2 bonds only. So add an hydrogen here. So this will be the structure of the purine. This will be the structure of the purine. Okay, so this will be the structure of the purine in this case. Now the formula will be like how many net carbons? 1, 2, 3, 4 and 5 carbons. So molecular formula will be C5, and the number of nitrogens will be 1, 2, 3 and 4. So nitrogen will be 4 and hydrogen will be like 1, and we got a hydrogen here, 1, 2, 3, 4. So 1, 2, 3 and 4. So 4 hydrogens. So the valency is satisfied, and this will be the structure of the purine. This will be the structure of the purine now. Now most interestingly, I told you the numbers, like this is the first position and this will be the second, third, fourth, fifth, sixth question, seventh question, 8 and the 9. Now we know this is the structure of purine. So this will be the structure of purine. So in purines we got two things, two examples for purine. One will be the adenine. So if you want to make the structure of adenine, this will be the structure, and in the sixth position, you replace this hydrogen, replace hydrogen by NH2. Replace hydrogen atom. In the sixth position, replace the hydrogen atom by NH2. So the moment instead of this hydrogen, if you write NH2, this will be the structure for adenine. Then second structure will be guanine. For guanine, the second position, instead of this hydrogen, you have to replace by amino group. So second position, instead of this hydrogen, you have to replace by amino group. So second position, you have to replace by amino group. So that we call it as 2-amino. And in the sixth position, the hydrogen is replaced by oxygen. So 2-amino 6-oxy purine. 2-amino 6-oxy purine.